Alright, for this video I'm going to go over my DJI F450 setup. Now this setup's primarily for FPV and aerial photography. Um, I've built a few X-Aircraft frames and a few scratch-built frames, but I've never really been too satisfied with them. I've had a lot of vibration issues, especially with the GoPro. But with this I'm really satisfied. Everything's worked out quite well. I get very little vibration from this motor and prop combination, and pretty good flight times as well. So I'm going to start off with, of course, this is the DJI F450 frame. Now I have these extended landing gear mounted to the bottom, and these are 3D printed plastic. They're secured with 2 zip ties, and they raise the frame up just high enough to mount the GoPro beneath it. If you had a gimbal or something, they wouldn't quite work, but they're perfect for if you're hard mounting the GoPro underneath. It keeps the props out of the view and gives some clearance, say if you want to mount a battery on the bottom as well. These are, of course, 3D printed. I sell them on my website. They're pretty cheap, and I have them in various different colors. Now, the flight controller itself is mounted on the bottom plate here, on the very center. This is the DJI NAZA flight controller with the GPS add-on. So here's the GPS antenna here. And the versatile unit, or the voltage management unit that's provided with the NAZA, is mounted right underneath the front arm here. And what that does is it has a bright LED indicator on it, as well as the USB port. So you want to make sure that the LED is visible from the ground, which is why I have it mounted right underneath the front arm. Now the GPS antenna itself is mounted to this aluminum mounting bracket. It has 2 cable ties securing it to the arm, and I use super glue to fix the pole in place. One thing you want to make sure when mounting this is that the red arrow atop the antenna is always facing forward. And the flight controller is mounted using the adhesive tape that's provided with the kit. Now the radio that I have on here is the FreeSky V8 FR2, and this is an 8-channel receiver. It has 2 antennas for antenna diversity, and of course 8 channels here. It also has a built-in failsafe, which is a great feature. That way, if your model drops out of range, you can trigger the failsafe mode and have it return to home, provided that you have the GPS add-on. Now, the receiver here, I'm going to go ahead and run through the 8 different channels that are on it and how I have them hooked up to my NAZA. Now, the first 4 channels, the first channel is aileron, followed by elevator, then throttle and rudder. And those 4 channels go straight to the NAZA. They go to the ports labeled A, E, T, and R. The 5th channel is the mode switch. So if you have a 3-position switch on your transmitter, you can wire the mode switch to the U port on the NAZA. The 6th channel here is for course lock, and that goes to the X1 port on my NAZA. And the 7th channel here goes to the X2 port on the NAZA, and that's what I use for setting dual gains for my transmitter. Now the final channel here, which is this 8th channel, which is for this wire, is actually wired to a relay, and that relay, once triggered, will supply the 4-cell battery voltage straight to whichever component I want. So for instance, I have several Hobby King LEDs mounted underneath the frame here, as you can see. So I have 3 blue LEDs on the right and left side, and 3 red LEDs on the front and back, and those can be triggered by the 8th channel. And since this is hooked up to a JST plug, I can easily swap it out for any other accessory that I want to turn on and off using a relay. Alright, now that takes us to the speed controllers. These speed controllers are the Hobby King 20 amp speed controllers with the 3 amp UBEC. The power leads from these speed controllers are wired directly to the power distribution board of the NAZA. I'm sorry, of the F450 frame. And these speed controllers have been reflashed with Simon K firmware. And I truly believe that these speed controllers are some of the best ones that Hobby King has. Looking at the reverse side of the speed controllers underneath the heat shrink, they use 6 MOSFETs as opposed to several smaller, lower current rated MOSFETs. So these should definitely last longer and be able to handle a wide range of currents, despite the fact that they're rated at only 20 amps. The motor leads coming from the speed controllers are wired up to 3.5mm bullet connectors, and of course they're secured to the arms with cable ties. Now the motors I have here are T motors. These are the MT2216 900 kV motors. They're great motors. Originally this setup had NTM 2826 1000 kV motors, and those motors were 315 watts. These are 210 watts. Both are rated for 3 to 4 cell usage. However, when I had the NTM motors on here, same prop configuration, same power setup and speed controllers, the motors would get extremely hot. I would say multiple times they easily exceeded 100 degrees Celsius. And in one instance the motors actually failed and the quadcopter came crashing out of the sky. So I would most definitely not recommend NTM motors for this type of usage. These T motors cost quite a bit more, but I can say they're well worth the price I paid. The bearings are unbelievably smooth, and after many flights the temperature of the motor casing hardly even exceeds ambient temperature. Even in temperatures outside during the summer when it gets fairly hot. So the props that I have on here are Gropner E props, and they're 9x5 props. They're very quiet and smooth. I have not had to balance these. They seem to work quite well without needing any balancing. And this combination of motors and props seem to give very little vibration to the GoPro. Now the battery I'm using here is a 4-cell 3300 milliamp hour Nanotech. It's a 25 to 50C discharge. I get about 13 minutes of flight time on this battery, which is really good. When the batteries are brand new it was closer to 14 minutes, but as I use them the flight time isn't quite as good as it used to be. Now the FPV system I have on here is the Hobby King 200 milliwatt video transmitter. It's 5.8 gigahertz, and I have it mounted right here back behind the receiver with homemade circular polarized antennas. Now the video transmitter here is generally rated to be powered off of 12 volts, but I actually have the video transmitter powered off of 5 volts. And the 5 volts power I have going to this comes from one of the open open servo ports for the gimbal outputs of the NAZA. So my hope was that the power coming from those ports would be quite clean, shouldn't be too much jitter or noise on those channels. So that way I get a clean power source for my video receiver without needing any separate voltage management unit, since I am running 4-cell batteries and you cannot power these off of 4-cell batteries, they get very hot. Powering it off of 5 volts from the NAZA seems to keep quite cool, but I haven't had any range problems or anything. It seems to work just as well. Now the composite connection I have coming from my HD Hero 3 Black Edition, and this is a new version of the GoPro. It uses a 10-pin USB connection as opposed to the 2.5mm composite connection on the Hero 1 and 2. So let's see, this connection here plugs right into the side. I had to purchase this cable directly from GoPro because there's the cable here is a 10-pin micro USB, and I don't have any 10-pin micro USBs that I can modify. So it was about $20 to purchase this composite cable, and then the composite cable I spliced into the wire right here, which goes back to the video transmitter. Now the composite cable does have left and right audio channels as well as video, but both the left and right audio channels are combined together. So I don't know if there's any way you could get stereo out from this. It seems that GoPro is only opted to make a cable that provides mono audio out. So with that, I'll move on to my ground station. Now the ground station is what I use for FPV, and this is a modulus Turnigy 9X radio. So this here I have a 7-inch LCD mounted to. The transmitter also has the LCD backlight modification, so when I turn it on here, you'll see that there's a backlight on the screen. It was very easy to set up. Hobby King has some photographs on their website showing the process used to install it. Now the 7-inch LCD screen is also powered off of the transmitter battery, so when I turn on the transmitter, the screen will also turn on, as well as the power for the video receiver. Now this is the receiver that came with the 200 milliwatt Hobby King 5.8 gigahertz video system. It also has circular polarized antennas on it, but I've modified the cable here so that there's two input and output connections in parallel. You have the orange cable, which is video. The red is 12 volts power, which is needed to supply the monitor and the receiver with power. And the ground cable is brown here, and that's the common ground. Now, the mount here for the LCD screen is a 3D printed mount as well. It has a tray that the receiver can slide into, and on the back here it has a knob. This knob came with the LCD screen, and that's what secures the back of the LCD to the mount. It fits quite easily. Now the mounting itself is actually secured using two M3 bolts directly to the handle of the Turnigy 9X. It's a very secure mount, no problems there. The antenna for the module goes straight through the back, and the power cables from the transmitter actually come through the open antenna port, since this is the modulus transmitter. Now, being a modulus transmitter, I had to install the FrSky DJT module, or FreeSky module. This is a telemetry module, and the receiver that it shipped with is not made for telemetry. So, if you do want to use the telemetry, you'll have to get a different receiver. But I don't intend to use telemetry with this, so I'm happy with this module and the provided receiver. It works quite well. The primary advantage is that you do have a fail-safe, so if the model drops out of range, it will trigger the channels to preset positions, and that way you can have the NASA enter return to home mode or fail-safe mode, and it should be able to fly back and land itself. Now, this also has the ER9X firmware flash to it. I direct soldered to the board inside. It was the cheapest way of doing it, and it's pretty straightforward. Flashing didn't take too long, and the benefits of the ER9X firmware are really good. I mean, there's a lot of stuff you could do with this firmware that you cannot do with the built-in firmware. This also has the LiPo battery mod, so there's a 2650 3-cell lithium polymer battery in here. With the LCD screen being powered, it lasts quite a long time. I would say I could get about 8 to 12 flights in, each flight being almost 15 minutes, and that's with the LCD screen being powered. So that's about it for the transmitter here. I will do a quick rundown of all of the switches that I have programmed. Now, this is using ER9X, so some of these functions won't be available with the stock firmware. But I'll begin with this back switch here. This is my relay switch. It's wired to channel 8, and that's what triggers the LEDs on my quadcopter. This switch here in the front is my dual gain switch, and this goes to the X2 port of the NASA. And what it allows me to do is switch between different gains in flight. So for instance, If I want to use it just for flying around, maybe some more, give it some more agile maneuvering capabilities, then I will leave this off and the gains will be set fairly low. And if I switch it forward, the gains will increase, not only the pitch and roll gains, but also the altitude gain. And that would be more suitable for aerial photography, so the movement would be more sluggish, but it would also be smoother and turn out better for video. This switch here is dual rates, and by default I believe the NASA requires that your rates be set to 100%, but by switching it down it decreases my rates to I believe 70%. Don't really use that switch too often, but it's there nevertheless. This is the 3-position mode switch, and the first position I have set to the rates mode, so gyroscope only. If I switch it to the middle position, I have attitude mode, and if I switch it all the way down, I'll have GPS hold, or GPS mode. Now this switch is the course lock switch. It's off by default, but by turning it on, it will lock the course in. It could also be set to home lock, but that's a setting that has to be changed from within the firmware. This switch here is a fail-safe switch, or return to home switch, so this will simply trigger the fail-safe mode and return the aircraft to its launch position. And finally I have this switch here, which is the momentary switch. And the way I have this configured is generally for the NASA you have to move the sticks into the bottom inside corners in order to arm the NASA. But by flicking this switch here and holding it, it'll change all of those channels to the arm position. So in other words, I can arm the aircraft simply by holding this switch as opposed to having to do the stick positions. As you will see on this screen, I can go here to the channel outputs, and when I flip the switch you'll see that it changes the first 4 channels such that it arms the aircraft. Alright, so that's everything for the switch combination there. And I think that just about sums it up for this video. I'll have links in the description for all the articles I've done. Those include write-ups on how to flash the transmitter. They'll include pictures and parts lists for the F450, and should have everything you need. If you have any questions, you can either email me through my website or leave a comment on this video. Thanks for watching.